Alrighty, Mr. Gatekeeper here. Have it's a cigarette, by the way. So you smoke in the video. But anyway, have a local fella, Mr. Lakeman. Little Fatboy 2x8 staged amplifier, base amplifier. Pretty neat little layout. Basically, the rectification system that was in it had failed, and a fire had took place a little bit back here. I don't know if it was just a quick flash fire, or I couldn't recall, but you could tell it had caught fire pretty well back here in the back. I probably spent at least 2.5 to 3 hours just in cleaning this unit. I mean, everything back here was completely black. And I figured out exactly the reason why that happened, or a very strong possibility. Here's the rectifiers that came out of it, 2 sets of 3. At least half of them are toast, for sure, if not all of them. I know this side right here is. Basically, it's kind of hard to show the back here. Let me see if I can get the camera back here. Back here in the back, where the 110 plug comes in, I usually like to try to use these strain reliefs, a plastic strain relief, to keep whatever insulated from the case here. But there was a metal type strain relief, and somehow or another the 110 plug had cracked just a little bit open, the insulation around it, and it appeared that the possible, I can't say 100% sure, but it appeared that what happened was one of the 110 wires shorted out against the case itself, and that possibly is what could have caused this. I'm not saying it's 100% sure, but I did notice that one of the there was some bare wire showing right there at the 110 plug, and it was pretty much touching the metal strain relief type thing that was in there, which was grounding out to the case there. So I went ahead and moved the ground for that too, that was right here, over to the back. Okay, that's the 110. You can also do an RF ground right there if you want to earth. So anyway, what I went ahead and did is I just pulled out these 6 rectifiers here. Went ahead and put you 2 what I like to call bulletproof 100 amp modules. I mean, these things are beautiful. The voltage does not drop as much when you're using these type modules right here. You don't have as much voltage drop. You're not having to use as many devices to equal up like you do with the 50 amp bridges there. So I love these, man. I know a fella that's been using them for a good little while now. He has not had not one fail on him yet. Not saying they won't. Anything man-made will fail eventually. Give a big major shout out to Mr. Real Deal over at DC Power, Real Deal DC Power. I took that heat sink there also, man, and gave it a good scrub down and got it looking shiny for you, man, just to get all the remnants of that fire or whatever. It was black, man. It was pretty rough right here in this corner right here. Okay, there was a fuse in there, which was adequate. There was a little small fuse holder. I think it went up to 30 amps possibly. What I went ahead and did is just put you a breaker back there, a 30 amp breaker. If you ever have a problem, you can just reset that breaker back there. And I'm not sure why these holes are being drilled in the back here. There were some over here too that I kind of hid with this big washer right here. I have no idea why those holes were being drilled. But anyway, it was kind of a mess. This big honking filter cap was in here just kind of laying, and it was just moving around. It had one screw that had came pretty much loose and was just kind of floating around in there. And I tested it. It appears to be it is possibly fine, but just to make things a little more neater and make me feel a little better, I went ahead and put you two brand new 57. Let's see here. Here, 57.6 is a thing. Let me see here. 56,000s. 56,000 microfarad caps, 1 per 100 amp transformer here. Okay. Went ahead and rerouted your wire. Gave you all brand new wire here for your 110. That's what you see them being ran down there. It was kind of just all spaghettied around everywhere before. Trying to just make everything look a little bit more neater. I cleaned your wires too, man. They were looking pretty rough. And cleaned your board for you too, man. You can tell the box had been ran pretty good. There ain't nothing wrong with that at all. There was one thing back here in the back that I did not agree with. Go ahead and pull it. I think I got it right here. Alright, you see this cap right here? This is a 1000 picofarad 500 volt cap. Alright. Back here in the back where you see this doorknob cap here, in between the doorknob cap and the relay was this. Now, we won't get real technical into things, but I could probably go ahead and guess that there's a little bit more than 500 volts worth of RF AC voltage flowing through, coming out of this box, man. And I just did not like that. I'm not too sure why that was there. I don't know if they just saw that. I really doubt that Fatboy put that there. I think somebody else might have done that. But basically, you just had this cap with this little bitty wire from here to the relay. So all the power of the whole amplifier was flowing through this capacitor. Now, there's nothing wrong with that at all with like a little 2 transistor amp or something like that. But 8 transistors, up to 1,000 RMS flowing through this capacitor right here, I don't like that. So I went ahead and took that off and just threw a nice little piece there of copper leading from there to there, pretty much the same size copper this coil is. So let's see here, man, if we get anything else here. I give props. It's pretty neat how they got everything set up. Like I said, it's staged. Here's your 2-pill section. Here's your 8-pill section. Okay, so you can run the 8-pill by itself and use another driver if you want to, or you can use the 2-pill by itself. Okay, and the way they've got that set up is, I don't really like the way they call that boost and all that. That kind of can confuse you. Basically, when you flip this to the middle, it's off. When you flip it up, it's utilizing the high tap on both of these transformers, okay? So you're floating at around 21 volts or so, and you're running at 100 amps of current, all right? Now, we both know that this 2 transistor section, these two 2290s, are not going to be enough to pull these 200 amp transformers down. You cannot run that way. So what they did to help with that is, when you flip it down like that, as you see, it's floating 17 volts, and when you key, it drops down to a great operating voltage. You flip the 2-pill section on. So basically, I would have probably named this a little different, because if you flip this down, you cannot run that 2-drive-an-8 section on the low tap of both of these transformers. I mean, the dang thing's dropping well below 11 volts. So pretty much flip this all the way down to run the 2-pill by itself. Okay, now if you flip this all the way up and run the 2-pill, you're going to risk blowing this 2-pill section, because you're going to be running on high volts. We're talking about 17, 18 volts possibly. Okay, so off, in the middle is off. Flip it down. You can run the 2 transistor section by itself. Both transformers is on the low tap, floating at 16 to 7 volts. All right, flip it up, you're in the high tap of both 100 amp transformers. You're ready to run both, or run an external driver into it and just run the 8 transistor section. As you see, you're floating at 21.8 volts at that point. Alrighty. Turn that back off there. And as you see, man, I went ahead and gave you all new power wires. The way they had it is they had pretty much a ground wire at all 4 corners of the board. I cleaned that up a bit. And one thing that was a little bit overbore is on the hot bus here, there were 5, let me repeat, 5 power wires going to the hot bus here. I unsoldered all these chokes here. And this is some real good thick 8 gauge here, man. Some of the highest strand 8 that they got on the market. So I went ahead and you're talking about 2 real thick highs 8s from straight here to here. That's perfectly adequate, man, for 8 transistors. I don't know how they fit it, but they did. They had 5 power wires going to that hot bus. So I pretty much, like I said, pulled all that up. I cleaned up the hot bus a bit. Did a lot of cleaning on this thing, man. A lot of cleaning. It looked pretty rough. It looked pretty rough. And I thought, well, if I've done all this work over here and cleaned up the whole power supply section, I might as well correspond over here. And you can look at these wires here, man. I mean, they were rough looking. Real rough looking. I went ahead and just went to the trouble there to clean them up, man. Got that looking good. Yeah, that's just appearance stuff, but if I'm able to, I like to give a good clean box back to a customer when I can. So, all right, man. Over here on the fans here, you probably noticed that you only had one fan that wasn't working. I went ahead and fixed that. A wire head came off. That's all that was, just a wire head came unsoldered from one of the regulators. So all 6 fans work now. So you're going to have that air pushing up under this heat sink and also pushing back here through this heat sink that these 2 100 amp rectifying modules are sitting on here, just out the back. All right, well, let me go ahead and show you this bad boy working. What we'll do is we'll flip it down. Turn 2-pin section on first. All right, we're just going to be hitting everything with the hot radio right now on this video. Neat thing too, the way they got it all wired up, once you flip that 2 transistor off and the 8 on, this variable is bypassed, okay? So right now the variable is working when the 2 transistor section is on. We're on the 100 watts, 1,000 watt slug, excuse me, 1,000 watt slug. That's right there about 100 bird. So that's about 300 watts. See, now look at this. Give you a prime example. You see we're on 16.5 volts right there, right? Now watch this. 14.2 volts. See? It drops just perfect there, being on the 2 low taps of the transformer there. So you flip this back off, flip it up high, 8-pin on. Of course, we ain't gonna get much out of it, but just to show you. 200 bird. Oh, yeah, 700 watts. But go ahead and flip both of them. 2 driving 8. Run off 2 100 amp transformers on the high tap. RMS. Go. There you go. 800 watts RMS. I'll show you a dead key. Go. Alrighty, just to show you the peak. That'd be off the 1,000 watt scale. I'll find my 5 kW slug. Let's see here. There she is. Alright. 5,000 watt slug. PEP. We're reading the middle scale where you see the 500. So the 20 is 2,000. Go! Right there, about 2,200 watts. 2,200 watts, PEP. So we got this bad boy back up and rolling for you, Mr. Lake Man. Mr. Lake Man out there around the Georgia area. Appreciate you dropping this bad boy off, man. It was fun working on it. And got your buddies one to do next. So it was fun, man. I'm glad it worked out pretty well. Hey, anytime I can get 800 watts out of the 2x8, I'm happy. You know, shoot. Got a little bit of, whenever you stage something, you do have a little bit of loss. You know, there's usually, I mean, not much, but you got just a little bit more loss because the RF is having to travel through the coax a little bit longer before it gets to wherever it's going. But she's working, man. No doubt about it. Well, you have a good one, buddy. I hope this thing lasts even longer next time for you. Go ahead and unplug all this stuff here. Well, actually, let me get this. We still got voltage in these caps, so let me get done with this video here before I go to unplugging anything. All right, buddy, I'm coming. All right, y'all have a good one. 73rds, gatekeeper around northeast end of Georgia's gone. Bye, bye, bye.